All right, this is still the Unit 1A review, Part 2, starting with number 14. We are solving this equation. So when you're solving an equation, remember you have some goals in mind. You're trying to, if it's an x to the first power, we're going to try to get all the x's on one side, combine them together, and then isolate the x. If it ends up being x squared or something bigger, we'll have different techniques. Like what will we be factoring? We'll be trying something else later on down the road in different units. So let's look at this first one and let's try to determine which method we're going to need to use. So to be able to do that, we need to distribute everything out and see what we really have. So we're going to multiply 9x times 4x, which would be 36x squared, and then 9x times 1, which would be 9x. Negative 2 times 4x would be negative 8x. And negative 2 times 1 would be negative 2. For this side, this is 6x minus 5 squared. You really need to write that twice because that's what it means to square. You are going to be distributing again. So this is equal to 36x squared minus 30x minus another 30x, and then negative times negative is positive 25. So if we clean up both sides, this ends up being 36x squared plus x minus 2 equals 36x squared minus 60x plus 25. Now it looks like for a minute you have an x squared problem, but they're both 36x squared. So if you try to subtract one over to join the other, they're going to zero out. So actually this ends up just being x minus 2 equals negative 60x plus 25. And that's from subtracting the 36x squareds over to join each other. They cancel each other out on both sides. So now we want to add the 60x over to the left side, and we'll want to add the 2 over to the right to try to get the x terms on one side and the non-x terms on the other side. So if we add over 60, that would be 1 plus 60, so that's going to be 61x. And then if we say 25 and then we add the 2 over, that's going to be 27. So then we would divide by 61 to get the x by itself. Now things that we'll need to check. Does any factors of 27 go into 61? If you don't know if 61 is prime or not, you need to do a check on this. So 27 divided by 3, remember, is 9. So do 3 or 9 divide into 61 evenly. So double check. So 61 divided by 3. Nope. 61 divided by 9. Nope. The only other factors of 27 are 1 and 27. 1's not going to help us, so as long as 61 is not divisible by 27, which it's not, you know that it's reduced. So this is the final answer. Now for 15 and 16 and I believe 17, these are all ones that have, actually just 15 and 16. These are all equations that have rational components to them. They have variables in the denominator. When you're trying to solve these, one of the methods is to multiply everything by the LCD to clear out those fractions. But that also gets rid of the fact that there are variables in your denominator. So anytime you're doing these, you need to make sure you know what the restricted values are. Restricted values are solutions that aren't acceptable, essentially. You cannot put this number back into the original equation because it would cause us to divide by 0. So the way you find those is you take your factored components, that's after you've broken up all the bottoms. These are already broken up. You set them, I always say not equal to 0 because we don't want them to equal 0, and you solve for p here. So this would be subtract over 4 and then divide by 3. So we don't want our final answer to be negative 4/3, or we also don't want our final answer to be what this would be if it equals 0, because we don't want to divide by 0 on this side either. So that would be add 3 over and then divide by 2. So we're going to solve this now that we know that these two answers are restricted and are not allowed as our final answer. Now one of the techniques is if you do have just a fraction on the left equal to a fraction on the right. So single fraction on the left, single fraction on the right. Notice how 16 does not have that because you have a plus sign between your two fractions on the left. If you have this, you can cross multiply or cross product. That's when you take the top of this left side and multiply it by the diagonal denominator on the right side. So this would be 3 times 2p minus 3, and then we set that equal to the diagonal multiplied from the bottom of the first to the top of the second. And I always just put my number in front because it's easier to distribute from there. So then if we distribute this, this is 6p minus 9 equals 18p plus 24. I would subtract the 6p over, so that's going to make this 12p. And then I would subtract the 24 over, which is going to make that negative 33 equals 12p. Divide both sides by 12. And since negative 33 over 12 is reducible, we can divide both top and bottom by 3. That's negative 11 over 4. Now, that is not one of my restricted values, so as long as I've done everything correctly in my arithmetic, this should be an acceptable answer. If you're not sure, you can always plug it back into the original and see if the left side matches the right side. Sometimes we will force checks because they are crucial because you have extraneous solutions. Other times I just hope that you would use your calculator and do your check. So let's look at 16. 16 is a similar type problem except we have two fractions on the left. So I'm going to use the LCD method here. The first thing we want to do though is factor all of our denominators. So I'm going to go ahead and factor this as an x plus 6 and an x plus 1. So my LCD looks like I need x plus 6 and x plus 1. Now that means my restricted values are negative 6 and negative 1. We do not want those to be our final solutions because this one would cause, negative 6 would cause this to be 0 in the denominator, which messes up the first and the last fraction, and negative 1 would cause x plus 1 to be 0, which messes up the second and the last fraction. We would be dividing by 0 if these were the solutions. So the way we work this out is we multiply each term in the equation by the LCD. So I always write it in a different color so you can see the LCD on each one. So that's the LCD times the first term plus the LCD times the second term equals the LCD times the last term. Now what should happen if you've picked your LCD correctly is that all of your denominators should cancel out and leave you with just stuff on top. So the x plus 6 cancels here. You take the numerator times what's out front, so it's going to be 1 times x plus 1, which we will distribute in a minute. The x plus 1's cancel in the second one, so that's a positive, and then a 3 times the x plus 6 out front equals, and then all the denominator cancels here with everything out front, so it's just 2. We distribute across the left side, add like terms. 1 plus 3 would be 4x. This would be plus, I don't know why I have another equal sign there. Hang on just 1 second. That's just supposed to be plus. And then this would be 19 equals 2. Subtract over the 19, so that's going to be 4x equals negative 17. And then divide both sides by 4. Negative 17 over 4 is an improper fraction. We leave it improper as long as it doesn't reduce, and it does not. 17 and 4 have no common factors. And it's not negative 6 and it's not negative 1, so the solution is good, as long as we haven't made any kind of arithmetic errors. All right, let's look at 17. This is an average problem. It says Matt scored 91 and 86 on his first two tests. What score does he need on his third test to have an average of 90 in the class? To take an average, remember we add the tests together. So he has the first test plus the second test plus the unknown third test. So X is standing for score on the third test. And we divide by how many tests, and they have to be equal weighted tests. So these are all 100-point tests. So since there's 100 points for each test, we're dividing by 3 equally weighted tests. And then we want that average to be 90. So the first thing I would do is probably clean up the top a little bit. 91 plus 86 would be 177 plus x divided by 3 equals 90. To get rid of the 3 in the bottom, we would times it since they divided by it. You do not need to distribute that to the top. It reduces immediately with the denominator. So this is 177 plus x equals 270. And we would subtract the 177. So it looks like he needs to score a 93. So 93 is the score that he needs to make on the third test to make an average of 90 in the class. Okay, number 18 is the work rate problem. We have that one pipe can fill a pool in 4 hours. A second pipe can fill the same pool in 7 hours. If both pipes are opened, how long will it take to fill the pool? So they're both working together in that last statement. So when we're talking about work rate, we need everything to be a consistent unit of job per time. So pipe 1, if we think about how long it takes him to complete the whole job, it takes him 4 hours. If pipe 1 is working consistently for that entire amount, which for this to be an easy problem, it has to be, we're assuming that, then that means that 1/4 of the job gets done per hour. A second pipe, so pipe 2, is also trying to do this job, and it takes it 7 hours. It's a little bit slower. So every hour it does 1/7 of the job if it works at a consistent rate. If they work together, which I like to call the combo, then we don't know how long it's going to take. That's what we're trying to solve for. So we're going to call that 1/x of the job per hour. Now, typically how this works is that if the two jobs are doing the same thing, they're both the same job, we add the solos to get the combo. If they were opposing jobs, like one was filling the pool and one was draining the pool, you wouldn't add them, you would subtract them because they're working against each other. Now, one way to solve this one, since the numbers are both on this side, is you could just get a common denominator, add the fractions together, and then use cross multiplication. And I'm actually going to do that in this case just to show some variety. So if we multiply this side by 7 to get that to be a common denominator with this one, which we're going to make 28 our common denominator, this would be 7/28 plus 4/28 equals 1/x. That makes that 11/28 equals 1/x. And now if we cross multiply, we get 11x equals 28. So we're dividing 28 by 11. Now we're going to probably have to round this. It said round to the nearest tenth. So it looks like 2.5. So approximately 2.5 hours. Okay, let's look at 19. A solution containing 9% concentration of acid is mixed with a solution containing 5% concentration of acid to get 100 milliliters of a solution containing 8% concentration of acid. How many milliliters of each solution is needed? So we have bucket 1 plus bucket 2 equals the final product. So we have on our shelf, we have a 9% mix and a 5% mix. We want our final concentration to be an 8% mix. So obviously we're going to be using more of the 9% because it's closer to 8. Our final product should also have 100 milliliters in it. Now, we don't know how many are in each of these buckets, but we can let the first bucket be X. The second bucket is always, if you're dealing with the two separate ones over here, it's how much would be left over from the 100, because this has to add up to 100. So the way we write that is 100 minus X. If you check, the X and the negative X would cancel if we just added the buckets together. So you'd just have your 100. So if this was 25, this would be 75. So that's how that's going to work. Okay. Now, you can change everything to decimals before you multiply, but since every bucket has a percent on it, we don't have to do that. If there was a bucket that didn't have a percent for some reason, you would need to change percents to decimals. So this is going to be 9x plus 5 times the second bucket, which is 100 minus x, equals 8%, which is 8 for us, times 100. So this would be 9x plus 500 minus 5x equals 800. That's going to be 4x plus 500 equals 800. Subtract the 500 and get 300 on the right side, and then divide by 4. So let's see what that comes out to. So 300 divided by 4 is 75. So they need, and that's from X. X is bucket 1. So we need 75 milliliters of the 9% solution. So 100 minus 75 is going to give us the other bucket. So that's going to be 25 milliliters of the 5% solution. So there's the answer for both. And units are important. So make sure you have your correct units on your word problem answers. Okay, for number 20, the directions say we're going to be solving by factoring. So if we're trying to solve by factoring, you want to make sure you have everything on the left side or right side, but the other side has to be 0. So we usually typically move everything to the left and get it equal to 0. Now, if my x squared is negative, I try to move everything to the side that makes my x squared positive. That's just my personal preference. But since my x squared is already positive over here, I need to move this 5 over. So we're going to subtract it over to join everything else. Negative 13 take away 5 more would be negative 18. So this is now equal to 0. Because we have a property that says if you can factor something on the left side, so a times b, and it's set equal to 0, then a has to equal 0, or b has to equal 0. Essentially, that's the options to make this equal 0. Okay, so a could equal 0 and b could equal 0. So that's how we're solving those. We get it factored and we set each part equal to 0 and solve. So factors of 18 that make positive 7, but it's making a negative 18 when we multiply, would be a positive 9 and a negative 2. When we set each of those equal to 0 and solve, notice that we have to move them over, so they change signs. So we get x equals negative 9 and x equals 2. For number 3, we're supposed to solve this one by completing the square. So to complete the square, first of all, you have to have a 1 in front of your x squared, and you do want everything kind of lined up like this. This is fine. So if you don't have a 1 in front, you divide every term in the equation by whatever would make that turn into a 1, so by the 3. You have to do it to everything, though, or you've not kept a balanced equation. So this is now x squared minus 8x minus 11 equals 0. The next step in completing the square is that we don't have a factorable trinomial over here right now. So what we want to do is create a trinomial that factors a very specific way. We want it to factor into the same binomial twice. That's called a perfect square trinomial if it does that. So the way we create that is we actually move the 11, the negative 11, over and out of the way because it is not giving us the nice factorable trinomial we're looking for. So we're going to add that to the other side. In its place, we leave a blank. And on the other side, we're also going to leave a blank because whatever you do to one side of the equation, we have to balance it and do it to the other. To create this perfect square trinomial, we need something very nice to happen with our last term here. The way this works is you take half of the middle term, which is the b, so that's negative 8, and then we square that. So this is half of b squared. So that would be negative 4 squared, which is going to be positive 16. Now we're going to write that in here, and I want to show you that that actually does factor into two binomials that are identical. Factors of 16 that add to negative 8 would be negative 4 and negative 4. They're identical factors. So whatever we do to the left, we have to also do to the right. So we're going to write that over there. Okay, so then this would be x minus 4 squared. So that, notice it's the part squared because it's the same binomial twice. And this now adds up to, it looks like 27. The reason we do this perfect square trinomial in completing the square is because once you get to this stage, you have a property that says if you have something squared on the left equal to a number on the right, you can take the square root of both sides as long as you write a plus or minus on the right side, the side that had the number. So if we take the square root of both sides, that's opposite operation, we need to write the plus or minus over here. So this just becomes x minus 4 equals plus or minus the square root of 27. We'll want to move that 4 over, so we're going to add it over, and we usually place it in front of the plus or minus. That's typical format. And then we do need to double check that this radical doesn't reduce. It actually does because 27 is square root of 9 times square root of 3. So this is going to reduce into 4 plus or minus square root of 9 would be 3 on the square root of 3. And notice that is two separate solutions, a 4 plus 3 square root of 3 and a 4 minus 3 square root of 3. WebAssign would make you split those up and write it as the first one is the negative one because that's the smaller one, and then the positive gets written second. Okay, for 22, it says we can solve this by any method. So first of all, you can't set these equal to 10. That is not what the property says. It says you set factors equal to 0. So we can't use that, but we can distribute this z and see what we get. So that would be 12z squared minus 7z. And then I'm actually going to move over the 10 as well. So negative 10 and then equals 0. I could try to factor this. So since it's a AC method problem, since the number out front is not a 1, I'm going to do 12 times negative 10, which is negative 120. Factors are 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and, let's see, 24, 6 and 20. Gotta keep listing. Does 7 go into 120? I don't believe so, but we're gonna double check. And 8, oops. 8 and 15. And actually I can stop there because I already know that's my pair. They need to have a difference of 7, and it's gonna be negative 7, so it's a positive 8 and a negative 15. So 12z squared minus 15z plus 8z minus 10 equals 0. It doesn't matter which one of these you write first. I can pull out a 3z out of the first pair. That would leave me with a 4z minus 5. I can pull out a positive, since it leads with a positive, and a 2 on the second pair, so that would also leave me with 4z minus 5. And then don't forget to bring down that this is equal to 0 because we are solving. This is different than factoring. With factoring, once you get the final answer written, you just leave it as all the products. With solving, we're going to actually solve it. So this is 4z minus 5 as the match, and 3z plus 2 is the extra binomial. So that's how that trinomial factors. We set each piece equal to 0 to solve. So for the first one, we would add 5 and then divide by 4. So 5/4 is one of my answers. For the second one, we would subtract 2 and divide by 3. So negative 2/3 is my other answer. All right, let's talk about number 23. For number 23, we're looking at, it looks like still a trinomial, but there's fractions involved. And whenever you see find the exact solutions, that usually means that this is going to have something that's not going to work out nicely. It's probably not going to factor. It could, but typically not. And that means I'm probably going to use quadratic formula to solve it because that's just the quickest way to deal with those. Now, you do not want to plug fractions into quadratic formula. That just makes your life messy. So I'm going to multiply everything on the left and right by 9 because that's the LCD of those fractions. So this would make this 9x squared. 9 times 4 is 36 divided by 3 would be negative 12x. 9 times 1 is 9, or negative 1 would be negative 9, divided by 9 would be negative 1, and then 0 times 9 is just 0. So just distributed that 9. Now I have an A, a B, and a C. So quadratic formula, remember, is x equals negative b plus or minus square root b squared minus 4ac all over 2a. So you place your numbers with their signs into the formula and we work it out. So negative b, well, b is already negative 12, so negative 12 is actually positive 12 plus or minus square root b squared minus 4ac all over 2a. So now we're going to work this out, and I'm actually going to move 24 down a little bit so we have room to finish this one. Okay, so we're looking at working out the inside of the radical first. So negative 12 squared is 144. So I'm going to work over here a little bit. So 12 plus or minus square root of 144. This is negative 4 times 9 times negative 1. So that's negative 36 times another negative would be positive 36. All over 2 times 9 is 18. We add together the part on the radical. So that would be 180 over 18. And then we have to check to see if there's any perfect squares that go into 180. I believe we know one of them for sure. 18 or 180 is definitely divisible by 9. That's a 9 and a 20. 20 has another perfect square and it's 4. So I'm actually going to try 36. Let's see if 36 goes into 180 evenly. And it does. So and 5 is not a perfect square. So the biggest perfect square that goes into 180 is 36 times 5. So I'm just writing that right there. So this would be 12 plus or minus square root of 36 would be 6. We'd still have a square root of 5 over 18. Now notice all of the outside numbers are divisible by 2, so we need to reduce this. So if we pull out a 2 on top, that would leave us with 6 plus or minus 3 square root of 5. Pull out a 2 on bottom, that would leave me with 2 times 9. So the 2's cancel. Actually, I missed something. Back up. Back up, back up. They're all divisible by 6. See, if you're not paying attention, you won't pull out a big enough number. So we pull out a 6 on top. So that would be 2 plus or minus 1 square root of 5, so just square root of 5 over 6 times 3. Now it's reduced. So this is, I'm going to write my final answer on top of here. So x equals 2 plus or minus square root of 5 all over 3. And that is exact because that is not been turned into a decimal. Okay, so let's look at 24. For 24, we're looking at another problem where we have an equation that has fractional denominator parts that have x's in them. So we're going to use the LCD method again, but we need to factor all of our denominators first. So this one factors into x minus 2 and x plus 2. This has an x in common you need to pull out first. Then you get x squared minus 4. So this is x times x plus 2, x minus 2. So actually, because of that x and that third denominator, that is now part of our LCD. So we have an x plus 2, and an x minus 2. And I already know I'm going to need a lot more room for this one, so I'm going to give some space. So I'm going to, and that means that my restricted values, we do not want x to equal 0 because that turns x into 0, or negative 2, or positive 2. Those are all restricted values. They would make our denominators 0. Okay. So we're going to multiply each fraction, remember, by the LCD. So x plus 2, x minus 2 times the first fraction equals the LCD times the second fraction minus, this time, the LCD times the last fraction, which has the whole LCD in the bottom. Ran out of a room right there. Okay, so in the first fraction, the x plus 2 and x minus 2's are going to cancel. So you still have an x and an 8x plus 1 equals, in the second one, the x plus 2's are gone, but we have a 4 times an x and then times the x minus 2. And in the last one, we have a minus sign, and then all the denominator parts cancel out, but we still have our 2. So don't forget your minus sign, don't drop that. If we distribute, this is 8x squared plus x equals 4x squared minus 8x minus 2. I'm going to move everything to the left because that will keep our x squared positive. So if we subtract 8 minus 4, that would be 4x squared. We're going to add 8x over, so that would be positive 9x, and we're going to add over the 2. Now we're going to do factor by grouping again. So 4 times 2 is 8. The only factors of 8 that can make 9 are 1 and 8. So this is going to be 4x squared plus 8x plus 1x plus 2 equals 0. If we pull out a 4x in the first pair, that leaves me with an x plus 2. The second pair has nothing in common, but we are going to pull out something. You have to pull out something. So we pull out the sign that it leads with, and then you always pull out a 1 if they have nothing in common. So that's also x plus 2. Don't forget my equal to 0. The x plus 2 is the match, and 4x plus the 1 is the second factor. If you didn't put that 1 there, you're going to miss that. Now we set each of those equal to 0 and solve. So we get negative 2 for the first one, and we get negative 1/4 for the second one because you subtract 1 and divide by 4. But negative 2 was a restricted value, so that means this solution does not work. So the only solution that works to the equation is negative 1/4. All right, let's look at 25. We're trying to simplify this expression that has imaginary numbers in it. So we're foiling, it looks like, because there's a times between these. So 4 times 6 is 24. 4 times negative 3 would be negative 12i. Negative 2i times 6 would be negative 12i. Be careful here. Negative 2 times negative 3 is positive 6. I times I is I squared. We learned in the section 2.4 that I squared is actually negative 1. So this is really 6 times negative 1, which is negative 6. So this is going to be, we combine our like terms. So the real number part is going to go first, and then the imaginary part. So 24 minus 6 is going to be 18. Negative 12i minus 12i would be negative 24i. 26, we need to do the order of operations here, so we need to do that exponent before we try to subtract. So we're going to write 6 plus 5i twice, and we'll distribute that out. And then I can go ahead and distribute this negative if I want. That's negative 9 and positive 2i. So let's distribute. This would be 36 plus 30i plus 30i. Be careful here. That's going to be positive 25i squared, which we're going to fix in a minute. Remember, that's really a negative 1 there, so that's going to make that guy negative 25. It changes signs. So this is 36 minus 25, so that'd be 11, minus 9 more would be negative 20, and then 30 plus 30 is 60, plus 2 would be 62i. And then the final question on the review packet is that we want to simplify this expression that has i's on both top and bottom. The reason we need to simplify this is because that I really is a square root of negative 1. That was another thing we defined in section 2.4. It's the imaginary unit. So because that, we have square roots in our denominator, so we don't want them there. That's, remember, something we rationalize out. So we need to multiply by the conjugate again of the bottom. So it's going to be 4 minus 3i. Now on top, that makes this FOIL, and on bottom it's also FOIL. So 3 times 4 is 12. 3 times negative 3i would be negative 9i. Negative 5i times 4 would be negative 20i. Negative 5i times negative 3i is positive 15i squared. And yes, we will have to change that to really be negative 15. Okay. On the bottom, we're distributing the conjugates. So this will be 16. You should get opposites in the middle, so negative 12i and plus 12i. And then be careful with the ending. This is negative 9i squared, which means it's going to change signs as well because of the I squared, but it ends up being a positive 9. The middle terms on the bottom are going to cancel because of their conjugates. So on top, this is 12 minus 15, so that's negative 3. And negative 20 and negative 9i would be negative 29i. And then on the bottom, we have 16 plus 9, so that's going to be 25. Now, that is not our final answer. We want to write this in a plus bi format, which means the real part and the imaginary part are separated. So what that means is you write them both over the denominator as separate fractions. And then you do want to double check to make sure that the fractions are reduced, and they are in this case. So that is the final question. So that's the end of the part 2 review for exam 1. Actually, that's not the end. I just caught a mistake on one of these. Sorry. Going back, I subtracted in my head wrong. 36 minus 25 minus 9. I was thinking it was negative 11 in my head, but 36 minus 25 is 11, minus 9 is 2. I caught that and wanted to make sure we fixed that. So this is actually a 2. So double check that, make sure you have that one correct. And now we are at the end.